Okay, I'm going to take you through a complete walkthrough of every component down to the wire of what I'm using on this system to help you possibly decide what you'd want to use on your system. I'll also include all the links to where you can buy these components below this video, so please make sure you check out the description box below to get the links and get more information on each of these items. What we have here are 4 Grape Solar 220 watt solar panels. These are 12 volts, and what I've done is I connected 2 sets. So I've got these 2 right here connected together. By connecting the positive and negative on one leg together, that turns this into a 24 volt system. And then I have these 2 over here set up in the same way. So let's take a look at the back here. So back here, hopefully you can see through the kind of upside down V there, you can see 2 wires connected with a yellow wire nut. One of those wires has a red piece of tape on it. I put red on every one of my positive wires. So that is a positive wire connected to a negative wire. That makes this into a 24 volt system. So I've connected 2 of the 4 wires from these 4 panels together. That means I have 2 open wires. Those 2 other wires, the other positive and the other negative, come down and they go directly into the back of the charge controllers at my battery bank. So here's a set of panels here that goes to one charge controller. Another set of panels go there, goes to another charge controller. Let's go take a look at the charge controller. Actually, before we look at the charge controller, let's take a look at this wire. I've got about a 55-foot run from my solar panels to my charge controller, and so I decided to go heavy duty on the wire. This is 6 gauge braided wire. So this is more than ample. This actually is over the specs on how large of a wire that I want. The reason why I went from 12 volt to 24 volt is because it keeps the amps down while increasing the voltage. What that means to me is that I can use actually smaller wire than if I use a 12 volt system. So I'm saving quite a bit of money by converting to a 24 volt system in the cost of buying wire. I did some calling around before I bought the wiring because I know it could be expensive. What I found is that this wire here costs half as much at an electrical supply store than it did at Home Depot. So check out your local supplies and compare it to Home Depot. But for me, I saved a lot of money by going through an electrical supply house. I just walked in as a retail customer, bought the lengths that I needed. I bought 4 55-foot lengths of 6 gauge multi-strand wiring. Okay, here are my 2 charge controllers. This charge controller goes off those first 2 solar panels. This charge controller is off the second pair of solar panels. Below here, you can see I've got 35 watt fuses. These are Stinger fuses. Again, I'll have the link below. You always want to have a fuse in between devices. So between my solar panels and my charge controller, I have a 35 amp fuse on both of these. Again, you can see it's on my positive wire here. Here I've got red wire. Here I've got the heavier gauge with the red tape. I really like these BZ MMP 500 charge controllers. As you can see right now, they're both, the battery bank is full and they're floating at 28 volts, which is exactly where I want them to be. So there's enough power coming in from the solar panels to charge the batteries, but the batteries don't need to be charged because they're already full. These charge controllers take care of that. From the charge controllers, I have my wiring going into the batteries. Let's take a look at that. Okay, so I'll go from the charge controllers right here over to my batteries. What I have here are 12 batteries. These are 6 volt golf car batteries, 215 amp hours. They are Rayvac Ultra Pro batteries that I purchased at Batteries Plus. I have this set up in 3 banks of 24 volts. So I have my power coming in from the charge controllers. The positive comes over to this here, and then the negative comes over to here. watch my other video on wiring to understand how I have this wired. Then I go from the battery bank over here to my Simlex 1500 watt pure sine wave DC to AC inverter. And between the batteries and the inverter, I have a 200 amp fuse. And to understand why I bought this specific inverter and why I have pure sine wave instead of modified sine wave, watch my inverter video. From here, I go to powering my house. This is what the front of the Simlex inverter looks like. Right now, if I wanted to run my house on solar, just turn it on and we're up and running. This pure sine wave inverter takes 1500 continuous watts and up to 3000 watts surge. From these outlets here, I go to my cables. Let's take a look at those. These are 3-prong extension cables. I bought male ends, and so I actually have male ends on both sides of the cables. Each of them goes into a kilowatt meter. This way I can monitor my use and I can know exactly how much power I'm taking out of the batteries in a 24-hour period. I know that these batteries will store over 15,000 watts. So by using these kilowatt meters, I can know exactly how much I'm taking per day and how much I still have in the batteries if there is no solar power. From here, these connect into an outlet that you would hook up to your circuit breaker panel. Now, of course, everything right here is in test mode. I have nothing professionally wired yet. So my last step would be to get a transfer box hooked up by a certified electrician into my circuit panel. And so when I want to go from off-grid to solar, and I'd only do that when there is no grid power, then I would go to the transfer box, flip the switch, and then plug these into the transfer box outlets and then monitor the use throughout the house. But by doing it this way, I can actually power my entire house, at least everything that I want to run in my house, safely, because I'm going through the transfer box into my circuit breaker panel, and then I can select what items I want to run in the house. Of course, the air conditioning would not be one of those. Really, a solar panel system is pretty straightforward. You only really need 4 main elements. You need solar panels, you need charge controllers, you need the batteries, and you need the inverter. Other than that, you've got wiring and fuses. Now, in addition to that, I do have a 24 volt battery tender, and I've got this hooked up. Again, to look at the wiring diagram, watch my video on wiring. And this trickle charges and maintains the batteries all at a nice float level. Typically, I have the battery bank being charged by the battery tender because I keep these 2 charge controllers in my Faraday cage. Again, the reason why I have this is when we don't have grid power. One of the causes of that may be an electrical magnetic pulse, whether it's man-made or solar-made. So to protect my charge controllers, I'll have these in the Faraday cage. If this burns up in an EMP, that's fine, but I don't want these to burn up. Another reason why I have 2 of these is because it's a backup. Actually, I could split this system into 2 different systems and be able to run it here and at another location. I have all the components that I need to do that, in addition to a second inverter. I've also purchased all the extra cabling and items that I would need to make it work in 2 locations at the same time. I also have a BLS battery lifesaver, which will extend these 10-year batteries to 30-year battery life by making sure that they're evenly charged and there is no buildup inside of the cells. Again, for all these items, look below this video in the description box for more information and additional reviews. Okay, so now let's take a look at what the entire system cost me. Okay, here's the list of all the items I've used in my solar panel system. My goal was to keep the cost to $5,000 or less. So this is what I have. I have my 4 solar panels from Grape Solar. Now, keep in mind, I bought these things a year ago, and I asked for a discount on everything I bought. So since I bought a bunch of batteries, 12 batteries, plus my niece bought 12 batteries, plus my sister bought 6 batteries. I asked for a discount. I asked for a discount on the controllers. I asked for a discount on the inverter. I asked for a discount on everything I could possibly get a discount on. So that was a year ago. I asked for a discount. I bought in quantity. So these prices may not reflect what they are today. But at least give you an idea of what I paid a year ago. So I have my solar panels here for a total of $1,740. My 2 BZ MPPT controllers. I have 12 6-volt batteries. I've got my 1 pure sine wave inverter. My battery tender to charge up the batteries when I don't have the solar panels hooked up, which is the majority of the time. My battery saver desulfator to extend the life of the batteries. I used pre-made 24-inch starter to switch battery cables. They're $4.50 each because it cost me less to have those pre-made just off the shelf at a local automotive store than for me to buy the ends and make the cables. Then I have my 4 different lengths of 6-gauge multi-strand copper wire at 60 feet each. I built the battery box that you saw. I have coasters underneath it. Make sure you get coasters that can take a lot of weight. I used 1/2-inch plywood or thereabouts. Then I have some miscellaneous items. So this is what everything added up to be, and my grand total is $4,642. So I'm very happy with that. Sometimes a controller will cost that much, depending on the controllers you get. So by getting just what I needed, I was able to save a lot of money. Now there are some items on the controllers that I'd love to have, but I wasn't willing to spend $2,000, $5,000 for a charge controller. So there are some things I don't have on there. But I have exactly what I want. I have what I need. I actually have a redundant dual system. I have enough battery power here to store 5 days worth of power if I limit my daily use to what I need to be. And that's 5 days of stored power in the batteries without any solar charging at all. So I hope this has given you an idea of what the components are that you need to build a solar panel system. Give you an idea of using the components that I've used, what it might cost you. And then you can do the math and if you want a larger or smaller system. Again, look at the bottom in the description box below this video for all the links to the best pricing that I could find for these items. So when you go shopping, you can save as much money as possible. If you have any questions or comments, if you've built a solar panel system in the past, if you have any recommendations, please make comments below. I'd love to have them. If you have a video response, I'd love to see it. We're here to learn and to share. There's a lot of interest in people being able to be off-grid for whatever reason so they have control over their power, and we would love to get your input. This is LDS Prepper reminding you, if ye are prepared, ye shall not fear. In addition, if you want to completely build a solar panel system and understand all the reasons why I bought the different devices that I have, please take a look at my other videos in this video series for the DIY solar panel system.